In this video, we're going to practice a few problems with systems of equations, and we're going to solve them with different strategies. So if I look at this example first, we're going to solve this system with substitution, okay? And so first, we need to know there's always a first step when solving with substitution. There's something we have to consider before we do anything. So what is that very first thing that we've got to do to our system before we can substitute? Okay, hopefully you chose that we have to choose one of these variables to get by itself. I either got to solve for this x, this y, this x, or this y. It doesn't matter x or y, it doesn't matter which equation, but I've got to get a variable by itself. I have to choose a variable and isolate it. And so then the next question is, which of these four is going to be the easiest? Is it easiest to get that x by itself, that y by itself, that x by itself, or that y by itself? Well, hopefully you're choosing this y right here. And the reason that y becomes the easiest variable to solve for is that it doesn't have a coefficient right here. What happens when we try to solve for a variable that has a coefficient is we often end up with fractions on the other side of our equation. Like, for example, we're not going to do this strategy. I don't think it's the most efficient. But if we wanted to solve this equation right here for x, I would have to start by adding y to each side of the equation. And then look, because we have this coefficient next to the variable, whenever I solve by dividing by -5 on each side, look how gross this gets. We end up with x equals 21 over -5 plus y over -5, and then that's the value we're going to have to substitute in for this x over here, and we have to deal with all these fractions. Notice these fractions were caused by this coefficient right here. So solving for one of these variables with a coefficient is not the most efficient strategy. We could, I can actually just clear all this off. We could solve for that y right there, but even then you got to remember to get rid of the negative in front of it, divide by that -1. But the easiest variable to solve for is going to be this y in equation 1. So let's get that y by itself really quickly. I'm going to add 4x to each side. And then I've got y equals 6 plus 4x is now what this equation is after I've solved it for y. And I'm going to copy down my equation over here. I'm going to try to be a little bit color-coded. I've got -5x minus y equals 21. And now we're ready to substitute. I can take this 6 plus 4x, and since it's equal to y, I can substitute in for y in the other equation. So I still have -5x minus y, which is 6 plus 4x, equals 21. So -5x minus y equals 21. And now we just solve. I'm going to distribute my negative. And I have -5x minus 6 minus 4x equals 21. Okay? I've got some like terms that I can combine. -5x and -4x make -9x when I add them. I'm kind of all over here with my colors right now. Excuse me for that. -9x equals 27. And then I can divide by -9 on each side and get that x equals -3. Once we know that x is -3, what should our next step be, if any? Okay, hopefully you were saying, now I got to go back and find y. So we got to take this value for x, and we can really substitute into either of our initial equations or even that form of the equation. It doesn't really matter. I might as well go with that form of the equation. But we got to do that to find y. Y equals 6 plus 4x, and that becomes y equals 6 minus 12. That 4 times -3 is -12, and that means y is -6. So our solution to this system of equations is -3, -6. What is the thing that you should always do in a system of equations once you find your solution? Okay, hopefully you were saying, I need to check my answer. I need to take that and substitute in, preferably into both equations to see if it works, but at least into one equation. So if I were to check my work, we've already established that our solution was negative 3, negative 6. And so let's just see if we get a true statement. Negative 5x minus y equals 21. That becomes 15. That becomes plus 6. 21 is equal to 21, so we're all good. Now, to be completely sure, let's check it in our other equation over here, because sometimes if we make a mistake in our calculations, our point will give us a true statement in one equation. But remember, we got to make sure this point is on both lines. So let's come over and check it over here. So I've got negative 4x plus y equals 6. Negative 4 times negative 3 is 12. Plus a negative 6 just means minus 6. 12 minus 6 is equal to 6, so it works. So we have just confirmed that that is our solution. We are 100% correct. There is no way that we missed this question now. So I suggest on your tests, go through and solve all these systems using substitution or whatever method, and then as soon as you finish your test, go back and check every question the way that we just checked it, and do that until you run out of time. I don't know if I would check as I go, because you might run out of time and not be able to do all the questions. All right, we got one more practice problem. We are now looking at this system. I've got my system of equations, and we're going to solve it by elimination or combination. Remember, those two are one and the same. So what's your first step? As I'm looking at this system and getting ready to solve with elimination or combination, what is my first step always going to be? Okay, hopefully you said, we got to get the variables lined up. I need to make sure that whenever I stack these equations on top of each other and add straight down, that my x's line up, my y's line up, my equal signs line up, my constants line up. And you can see currently that's not the case. Here we've got x and y on the same side of the equation. Here we've got x and y on different sides of the equation. So you can have it in any form as long as the two equations line up, but I prefer to go to standard form. So I like right here, I'm just going to flip that equation around. I can do that. I just took the left side and wrote it here. I took my negative 1 and wrote it there. And then over here, we need to get x and y on the same side of the equal sign, and it looks like we want them both on the left side. So I'm just going to subtract x from each side of the equation. And we end up with the equation negative x plus y equals negative 1. And now all of our variables line up, and I can write my equations together like this and get ready to do our elimination. Now, before we do elimination, we need to look for a variable that will cancel out. We need to either have our x's cancel out or our y's cancel out. Because currently if I add straight down, I would end up with, let's see, 2x minus x is x, negative 3y plus y is negative 2y, and negative 1 plus negative 1 is negative 2. And this really gets us nowhere because we still have these two variables here. So my next step is to figure out, what am I trying to cancel out, x's or y's, okay? And in this case, you could do either. I could cancel out my y's or my x's. And so let's do this. If you wanted to cancel out the x's, what would you multiply equation 2 by? Okay, hopefully you said you multiply equation 2 by 2, because we're going to make this a negative 2x, so it will cancel. But you could have also said if you want to cancel out the y's, you would need to multiply equation 2 by 3, because if this became 3y, then those would cancel. But let's cancel out our x's for this example. So what I'm going to do is I'm going to free up a little bit of space here to the side, and I'm going to multiply equation 2 times 2. Okay, and you got to be careful here, and I'll copy over my top equation. My top equation is 2x minus 3y equals negative 1. But my second equation, you got to make sure you multiply everything by 2 here. Remember, the whole reason we do this is because if we multiply the left side of the equation by 2, we have to also multiply the right side of the equation by 2. Okay, so negative x times 2 is negative 2x. Y times 2 is 2y, and then negative 1 times 2 is negative 2. We are now ready to add straight down. Those add to 0. Negative 3y plus 2y is negative 1y, and negative 1 times negative 2, or excuse me, negative 1 plus negative 2 is negative 3. I then solve for y, and I get that y is 3. Once I know that y is 3, I then need to go back and find x. It doesn't matter which equation I use to find x, I'll just pick this one. So if I bring that equation down, and I know that y equals x minus 1, we've already established that y is 3. And so once we have that, we can solve for x pretty easily. I'm just going to add 1 to each side of my equation, and we end up with x is 4. So when x is 4, y is 3. That's our solution to our equation. And so what should we do next? If you answered that we need to check it by substituting it into our equations, you're exactly right. So let me bring our equations down. I've got negative 1 equals 2x minus 3y. I also have my other equation, which is y equals x minus 1. And let's just check it. We're going to substitute 4 in for our x value, because remember, this is a little x value. We're going to substitute 3 in for our y value. And so I have negative 1 equals 2 times x minus 3 times y. And let's see what this becomes. Negative 1 equals 8 minus 9. Negative 1 equals negative 1. Check. We've just confirmed that this would be a point on this line if we were to graph this line. Now let's do the same for our other equation. We have here that y equals x minus 1, and that's pretty easy to check. 3 equals 3, so it's a point on that line as well. So after we solve this by elimination, we then substitute into both equations to make sure that we got a true statement, to make sure that it works. We now know without a doubt that this is the solution to the system. That was our last example. We're going to do one more little thing where we just kind of have a brief discussion. Because the good thing about using all these different methods for solving systems is that you can identify the one that's easiest and use it when it's easiest for you. So I want you to look at this first system and tell me which strategy is going to be easiest for solving it. Should we solve it by graphing, by elimination, or by substitution? Okay. Hopefully you were looking and you were seeing how all these variables are lined up. You were seeing the 5y and the negative 5y, and you're thinking, oh man, that would be a perfect one for elimination. Okay? That's definitely one for elimination. Now, look at the next one. What do you think about number 2? What could you do there? Okay, some of these answers are, open to discussion, but I think here your most efficient route is probably going to be substitution. Notice how equation 1 is already solved for y. So we are ready to take this value and substitute it in for y in the other equation. I guess you could probably justify a few different ones. I just think that substitution is going to be the easiest there. And so, as I said, number 2 is good for substitution. I'll abbreviate. And then lastly, number 3, which method do you think would be the easiest here? Okay. There's no one right answer. It's good that we're well-rounded. We can do all of our strategies, but I think this one's set up for graphing. Specifically because they're both in slope-intercept form. I mean, I can easily plot a y-intercept of -1 and do my slope from there. I can easily plot a y-intercept of 4 and do my slope from there and see where these lines intersect. So we've covered a lot in this video. Hopefully we've gotten better at not only solving systems with elimination and substitution, but hopefully we kind of start to get the wheels turned on how we can identify the easiest strategy to use depending on how your system of equations is set up.